The objective of this video is to work through an example of applying the definition of prediction to categorical variables. So to review, the definition we offered of prediction was that x predicts y if and only if there exist two different values of x, x1 and x2, such that the probability of y given we observe x equals x1 is different than the probability of y given we observe x equals x2. So let's take a case of baby gender. You may have confronted a situation like I have, where you've met someone on the street with a baby, and you need to be able to have conversation with that person as if you already know the baby's gender because you've met them before and you're supposed to have remembered. So you need to predict the baby's gender. How do you do that? Well, one option is to say 50-50, take a random guess. Not very good strategy. Even if we took a sample of 12,000 babies across a city and we observed it was 50-50, we wouldn't get very far. But now suppose you look inside the carriage and you see, they're wearing blue clothing. Well, now you have some real evidence, because it turns out from the sample we've taken that the probability that the gender of the baby is female, given they're wearing blue clothes, is only 15%, and the probability that they're male, given they're wearing blue clothes, is 85%. Why are 15% of the babies female that wear blue clothes? Don't know. Perhaps the parents want to make a political statement and not obey the usual stereotypes for clothing and baby gender. Perhaps they're using hand-me-down clothing from an older brother, even though it's a girl. Okay, so we can look at the value of the information we got by comparing the frequency, or the histogram, of gender before we learned anything about the baby's clothing color, to the frequency or the histogram of gender after we learned the clothing color. Now, in this sample, we actually had 4 different kinds of clothing color: blue, pink, purple, or green. And as it turns out, the chances that a baby is female or male, given they're wearing purple clothing or given they're wearing green clothing, is just the same as if we knew nothing about their clothing whatsoever. So the probability of gender female is 50-50, female given clothes purple, 50-50, female given clothes green, 50-50. And this illustrates the point about why there only has to exist 2 different values. Not all values have to be predictive. So does clothing color predict baby gender? Sure. Because there exist 2 different values of clothing color, namely blue and pink, such that the probability of gender given those 2 values is different, even though there exist 2 other values, purple and green, such that the probability of gender given those 2 values is basically the same. So in summary, clothing predicts baby gender because the probability distribution of a baby's gender, given it's wearing blue clothing, is very different than the probability given it's wearing pink clothing.